like to welcome you and welcome everybody that's in the room or joining online to the 16th uh, year of the China International Food Safety and Quality Conference. Personally, for me, my heart ached that I can't be there in person and meet everyone, but this is my 14th year of joining the conference, and also I always want to bring up the fact that my employer, Conagra Brands, are a very proud and strong supporter of the conference for everything they do. Really wonderful. I hope everybody in the plenary session got to see our commitment to food safety and quality, and got to watch the movie too, the video. But we're gonna start, and I would like to introduce Dr. Lan Tao, and he will cover for us the standard development of NMN determination of food and in cosmetic and in food and cosmetic. He will be much better able to definitely explain to everyone what all these nice big words mean. But Dr. Tao is a graduate of the Shanghai Jiangtong University, where he got his doctorate degree in chemical engineering. And also he did postdoctoral research at the University of Oklahoma. And since 2015, he's been working as an associate researcher in the prestigious China National Institute of Standardization. And his research is emphasizing a lot in the agricultural standardization and development of standard sample for agricultural products. Go ahead, Dr. Tao, and we'll start.
Okay, thank you, Joseph. Thank you for your introduction, and I'll start my topic. And this is Tao Lan from China National Institute of Standardization. And today my topic is about the standard development of NMN determination in food and cosmetic. And I will introduce my topic in this four part. First of all is the background, and NMN is a very new reference material of dietary supplement, and it is the beta nicotinamide mononucleotide, and it is the precursor of NAD, which is synthesized in human body. NAD can significantly delay aging and prevent some health disease, such as Alzheimer's disease. And with the increase of age, the level of NAD in the body naturally decreases. And the animal body gradually aged, and it was also naturally existed in animal body and food, such as avocado, mushroom, broccoli, etc. But the content in this food is very tiny. So if the body needs to raise the content of NAD or NMN, it can also use the dietary supplement which contain the NMN. So the NMN dietary supplement is very hot these years, and this product is very popular in the market all over the world. And according to the data, the market scale of NMN health product in China will reach to 5 billion yuan in 2020, and with a year of growth of more than 30%. And also estimated that in 2023, the market will grow to 27 billion yuan with nearly 70% growth, and it will develop rapidly. and we checked the NMN health product in our some e-commerce platform, and we found the price is very high, and the product sells very good. And we found the average price of an NMN dietary supplement on e-commerce platform is about 1,050 yuan per 60 capsules, and it's about 25 yuan per capsule, which is very high. So as a new rough material of a dietary supplement, so in different countries, it has different management. In Japan, the Ministry of Health and Welfare, they expressly stipulated that NMN can be used for food production, and enterprises can apply for filling function claims. And in USA, as a derivative of vitamin B3, it is allowed to be used as a rough material of dietary supplement. And in Canada, the Ministry of Health and the Health of Canada take the initiative to accept NMN as the natural health product, NHP, and it is expressed that the NHP will include in the rough material and claim list. But the rough material of NMN have not been approved in China. So the related product cannot be produced and operate as food and sell as food in China. I think the reasons is about like this. It's a lack of rough material and product quality standards, and lack of testing method standards. So the government and the enterprise cannot be able to control the quality of the product. And also the government is lack of the function of NMN, a function claim management of NMN. So right now, it cannot be approved in China. So as a very hot spot, so we did some research on this rough material, and we did some detection method of this NMN in food and in cosmetic, and we did this detection method and make this detection method into the standard, and we apply this two standards to different association to be association standard, and this apply is accepted. This to apply was also accepted by these two associations. And we also did some reference material, and we used the rough material of NMN to be, and we purified it and we make it to be the national reference material, and we did the application and waiting for the project approval. Next part is the determination of NMN in food, especially in the dietary supplement. And first, we studied the type and the number of NMN product in the e-commerce platform, and we found there are 48 capsule product and 6 tablet product. And we did the research about the content of each product in each capsule, and we calculate it into the microgram per gram, and we found the NMN in this 54 product ranges from 95 milligram per gram to 500 milligram per gram, and the average is 300 milligram per gram. And we think we can use the HPLC method and need to be use the dilution method. And after that, we choose the matrix as capsules and the tablets, and we choose the detection method as HPLC. But in HPLC, as we know, the reversed phase is commonly used, but the polarity of NMN is relatively very high. So in the reversed phase, it cannot be, it has no retention. So we use the helic column as the separation column. And in the pretreatment method, we did the optimization of several extraction solvent, and we did some purification method. And after that, we did the methodological investigation. First of all, we did the optimization of chromatographic conditions. First is the mobile phase proportion optimization. We used 50% of mobile phase A and mobile phase B, and 85% of this mobile phase A and mobile phase B, and 95% of mobile phase A and B to separate the NMN tablet and the capsules. And we found with the 85% and the 95%, the NMN can be separated from the matrix, and the separation is very good. But with the 95% of mobile phase A and mobile phase B, the retention time of NMN is about 8 minutes. It's larger than the 85%, and in order to reduce the detection time, so we choose the 85% of mobile phase B as the mobile phase. And after that, we did the optimization of mobile phase ionization conditions. We add some formic acid into the mobile phase, and we found with the add of formic acid, the separation can be good. And we did the optimization of a pre-treatment method. We used the pure water, 85% of methanol solution, and 50% of methanol water solution. And we found we used the recovery rate as the index, and we found in 50% of methanol, it would be the recovery rate is very ideal, and I think After that, we think as the matrix and the NMN tested in this method, it can be separated very good. So we think we don't need to do the purification, and without the purification method, it makes this method very efficiency and reduce the cost of the method. And the linear range of this method is about 5 to 500 microgram per milliliter, and LQ is about 3 milligram per kilogram, and the recovery rate, precision, and stability, repeatability is very good in this method. And we use this method to test the actual sample, and we found some difference between the detection value and the nominal value. And after that, we did this detection method, and we found this detection time can be controlled within 30 minutes. And this method has the advantage of a simple operation and high detection efficiency and good accuracy. And the method standard was formed. And we call 5 companies to do the validation of this method, and right now there are 2 companies complete the validation, and their result is good, and it showed this method has a good university. Next part is the determination of NMN in cosmetic. And first of all, we check the NMN cosmetics in e-commerce platform, and we found there are 3 kinds of product, such as facial mask, facial cream, and facial emulsion. And the product is not very few, but the price is very high. The average is about 500 yuan per box, which is very little. And as there's no detection method standard, so they haven't labeled the content of NMN in each product. And we choose this matrix as facial mask, essence, and facial cream, and facial emulsion as the matrix. At the same, we choose HELIC HPLC as the detection method. In this part, in this pre-treatment experiment, we did the optimization of extraction method and purification, because the facial mask essence is water phase, and the facial cream and the facial emulsion is lipid. It's lipid, so the pretreatment may be different. So we optimize the purification. And next is the methodological investigation. First of all, we use the HELIC and reverse phase column to check which one could be better to separate the NMN from the matrix, and we found HELIC is better. And in reverse phase, the NMN has no retention, and it cannot be separated from this 3 matrix. And we optimized the mobile phase, and this is also used the water solution with 0.1% formic acid as mobile phase A, and the methanol as mobile phase B. And we use 3 different different level of mobile phase A and B to do the separation, and we found with the 85% B, the separation is good, and the NMN can be separated from the matrix. Next is the optimization of extraction solvent, and we also use this full kind of solution to do the extraction, and we found with 50% of methanol aqueous solution, the recovery rate is very good. So we choose the 50% of methanol as the extraction solvent. As the facial cream and the facial emulsion is the lipid phase, so it may be need to be demulsified. So we use the demulsifier to do the demulsify. But we found with the demulsifier, the separation is very bad. So we choose to apart this kind of experiment. After that, we optimize the purification. We use a purification column, which can purify the lipid from the matrix, which is shown in this 2 picture. And the lipid can be purified by the column. And we also use the recovery rate as the index to show the result of purification column. And we found the second column is good. This is the result of using the column. So this is the experimental flowchart of this detection of an NMN in cosmetic. First of all is to accurately weigh 1 gram of facial mask essence solution, facial cream, and the facial emulsion samples into 50 milliliter centrifuge tube, and add 10 milliliter 50% of methanol aqueous solution. Vortex for 2 minutes and mix the solution well, and ultrasonic extraction twice in 20 minutes, and using the purification column to purify the extraction solution. And the purified extract will need to be centrifuged at 14,000 RPM for 10 minutes. And after that, take this supernatant into the filtrate the membrane. And after that, the solution can be used to be detected. And the methodological investigation, we also choose linearity, precision, accuracy, and recovery rate, and actual sample. to be tested. And in this method, the linear range is 2.5 to 500 microgram per milliliter. And the LOQ is about 2.5 milligram per kilogram. The precision, stability, repeatability, and recovery rate is all, they are very good. And we found we collected seven kinds of actual sample, but we found only two sample can be detected. They have the NMN, and five kind of this product don't have the NMN, but they labeled they have the NMN. And also this method was making this standard. So the summary is like this. First, we need to carry out the validation according to the validation report. We also choose 5 companies to do the validation. Next, to need to accelerate the release of 2 test method standards. And we want to do this. We want to use this method to promote the high quality development of NMN related products. Okay, thank you.
Thank you so much. I didn't know. This is great information, and we have a couple of minutes if anybody online or in the room have any questions. If you're in the room, use the mic. If you're online, you can send it through the Q&A. Okay, I do have a question, Dr. Tao. You mentioned that those methods are being currently validated. So is this validation going to be like, since it's been approved in the US and Canada and Japan, hopefully it gets approved in China for food also, but like, has it been validated through AOSC method, or what kind of validation you're working on?
Okay, thank you for your question. In our we use ISO 5275, this standard to do the validation. ISO standard.
Wonderful. And we still have 1 more minute. If there's any questions, let me see if there is any online. Anybody in the room have any questions? If not, I have 1 more question. And you mentioned that NMN also can be used for dietary supplements, right?
Right.
How stable is it for heat? Can you add it in a powder form to hot drinks, or it's possible to get it to mix, or or because it's a lipid, it's a problem?
So I think yes. We did the experiment. We use this NMN rough material. No, the reference material. You know, we did this NMN reference material, and we use DSC to mention the to detect the inorganic content of NMN, but we found it's and we use 5 centigrade Celsius grade of temperature to make this rough material dry, and we found the rough material is very stable at 50 degree.
50, yes.
Yes. And
wonderful.
As a good dietary supplement, I used to eat them.
I appreciate it, and if I have more questions, I have your email.
Okay.
Thank you so much. Really appreciate it. We're 1 minute behind, so I would like to introduce our next distinguished speaker, Dr. Lu Yu Shen. And I don't know if you have your camera. You are in person, actually. So this is great. Is Dr. Lu Yu Shen available? Is he?
I think the video is pre-tipped.
Oh, it's pre-taped, so you're gonna play it? Okay. I'm sorry it wasn't written here that it's pre-taped, but let me introduce Dr. Liu Shen. He's currently a professor at the very distinguished Institute of Animal Science and Veterinary Medicine in the Shandong Academy of Agricultural Science. He's going to talk to us about the progress and application of a very interesting subject, bacteriophage pharmacology, and look forward to hear about it because it is a very, very interesting application and evaluation for such a unique material that can have synergetic antibacterial and definitely we will hear from Dr. Yu Shen. And let's start. Go ahead and play it. Thank you.
首先呢，感谢主持人，感谢 CIFSQ 大会的邀请。各位同行，我给大家分享的题目是噬菌体药理学研究进展及其应用。我来自山东省农业科学院畜牧兽医研究所，主要从事公共卫生研究，基于对人畜共患超级细菌监测评价，开发呢疫苗、抗生素、噬菌体、益生菌和中草药，并将其组合为 WAF 来防控超级细菌，以促进呢农牧业这个流通和生物安全。那么噬菌体呢离不开流行病学的监测，也离不开对抗药性的这样一个评估。那么先给大家埋下一个噬菌体的种子，了解呢就是整个我的汇报的大致内容。那么我们知道呢，噬菌体是细菌的病毒，是可以特异性结合宿主菌，大量复制、变异并裂解宿主菌的活体药物。那么它为抗菌药物药理学呢增加了多样性、变异性、增殖性和特异性这样一些新元素。那么我这个报告呢就试图呢总结噬菌体药理学的范畴和技术框架，建立了噬菌体、抗生素这样协同抗菌的评价优化方法，提出噬菌体呢可行的管理策略，来介绍呢协同抗菌在提高抗菌力和降低抗药性的研究进展。那么我们知道抗生素疗效呢，它取决于对抗药性和抗菌力的平衡，对吧？那么抗生素它要取决于选择性独立的剪刀差，就是对人呢是安全的，对病原菌呢是有杀菌作用。实际上它是作用两个对象，一个是动物或者人，另一个是病原菌。它有两套药理学体系，一个是对病原菌的药效药代，另一个对 动物的药效药代。实际上呢，我们是把对动物的药代和对病原菌的药效呢，把组合成抗菌药理学，对吧？把动物的这个药效呢，再把它当成这个毒副作用来研究了。那么对病原菌的这种药代呢，我们把它当成抗药性来研究了。实际上呢，抗药性的本质呢，实际上就是病原菌啊对抗生素的这种代谢的过程，对吧？那么细菌的种类，就是细菌的数量和这增殖的周期和变异的速度都是非常快的。那么这样呢，像抗药性的本质，一个巨大的这个抗生素的缺陷呢，就是菌变了，但是药这抗生素它没法变，而且抗生素种类非常有限，对吧？这就造成这种全球性的这种重要的抗药性公共卫生这个难题。那么有没有这个种类丰富而且可变的药物呢？那实际上噬菌体呢就是嘛。那么我们回顾一下这个传统的抗菌药物药理学，它包括药代和药效两个方面。那么在药效方面，就体外的药品实验就是来评估抗生素的抗菌力。那么体内的药代呢，就是包括这个是药代动力学的曲线，对吧？对实践的这种依赖，对药物浓度的依赖，对吧？给出各种参数。同时呢，也有这个 PK、PD 的结合，也包括抗生素联合药品实验的这样一些方法，对吧？这大家都熟知了，就不这个介绍。那么去了药代这一块呢，药效呢，核心的就是药品实验。我想重点这个强调一下什么呢？就是不同的接种量对药品实验的结果是不同的。比如说高的接种量，那么即便是很高的药物浓度，它也不可能把这个抗菌力呢，就是把这个菌量降到0，对吧？相反呢，比较低的接种量，比如说我们药品实验是10的5次方的每毫升的接种量，那么我们低的接种量情况下呢，那么它的抑菌曲线就可以压得很低，就是它的表观的 MRC 呢就可以降低，这个非常重要的，对吧？就是我们药品实验的这个标准的方法，大家都横向的可比的，但是在临床上呢，菌量是一个重要影响因素，对吧？那么另外一个药品实验，它的判定标准我们都知道 ，MRC 低于敏感的临界值 S， 那么它的疗效是可靠的。但是大家往往忽视了，就是即便是 MRC 大于2的时候，疗效不可靠，它仍然有疗效，而且就是有其他协同抗菌因素存在的时候，比如说免疫，比如说噬菌体，它可以表现出一种协同抗菌的这个效果，对吧？那么这一个抑菌曲面呢，就是更直观的来展示着不同的接种量、不同的药物浓度和不同的时间，它这个动态的过程。那么抗药性的本质呢，我们可以通过这个实验呢，这个更直观的看出来，就是500个细菌在这个 N 诺沙星浓度不断提高的这样一个培养基上，它的菌量呢，就是培养12小时，它残存的菌量呢，它逐渐下降，呈现一个 S 型的曲线。那么对这个 S 型的曲线呢，它是菌的数量的这个曲线，我们来微分就取它导数，那么它就是一个正态分布的这个曲线。这表明这个细菌啊对抗生素的敏感性，它不是同质化的，而是抑制性的。就这群细菌呢，大部分呢它集中在这个部位，对吧？那么这个抗生素浓度能够杀灭它，但是还有一部分呢特别敏感的菌株和特别抗性比较高的菌株。那么在这种药物作用下呢，不管抗生素还是噬菌体作用，那么它这些高抗的这些菌株呢就会被筛选出来。那么它们两个的选择方式不一样，结局就不一样。我们看，那么这是细菌一个菌群，对吧？我们用抗生素就像一把刀似的切的浓度低了，它没有疗效；切的浓度高了呢，它会使这个抗性的菌株形成新的菌群。 那么你再切，对吧？这样一步步的就把抗药性的这个越来越高的菌株呢给筛选出来，形成一个高抗的菌群，对吧？那么疫苗呢，它通过免疫系统来起作用。那么只要说针对它流行菌株啊，那免疫系统还是可以忠实的来抑制它的病原菌，但是疫苗审批的周期还是非常漫长的，对吧？那么它不能很好的跟踪这病原菌。那么噬菌体呢，我们可以看到，那么以这一群细菌的来作为宿主菌来筛选噬菌体呢，它必然可以呢很好的来裂解它这个菌群的主体。那么参与这些对这些菌群呢有变异的这些抗性的菌株呢，就这个重新形成新的菌群。那么新的菌群呢，我们也可以从这个噬菌体变异的这种噬菌体里边来筛选新的噬菌体，对吧？来抑制它。对吧？这样就可以，因为它种类是可以说无穷无尽的，对吧？那它就可以步步的紧跟，而且呢，我们可以用多个噬菌体把它组合起来，就多个受体的噬菌体组合起来，来共同来压制这个菌群，那么它就不容易再反弹。那么益生菌和消毒剂，一个是干扰，一个清场，又不一样。那么在临床上呢，我们应该把这几种措施呢，把协同起来，来防止超级细菌。那么之前呢，就是因为我们依赖和单一的使用抗生素，才造成超级细菌这种局面。那么后边呢，我们就需要这个协同抗菌。那么面对这种全球性的抗药性危机呢，我们国家呢也给国际社会一道，来制定了这个仁义的和兽医的这样一个遏制细菌的行动计划，国家行动计划，对吧？来寻求这个策略和方法。那么遏制动物源细菌抗药性的国家行动计划，它分6大行动。那么主体上实际上就抗性监测、抗生素减少使用，再一个呢就是这个抗性降低，对吧？这个简单来讲就是健康、减抗、降抗，这么3个核心的内容。那么为此，那么这个呢，国外有些政策呢，我们也可以借鉴。你比如丹麦，他们主要是靠政策来把抗药性这个降低下来、控制下来，而不是说依赖，比如说我们的抗性机制啊、抗性基因这样复杂的一些研究。那么他们一个呢，建立抗性监测的计划，有监测来作为基础，第二个呢，他们花了5年的时间，把抗生素促生长剂从饲料里边把禁用了，把一些高级别的抗生素呢列入兽医禁用的名单，对吧？再一个呢，他提出一个黄牌这个警告这么一个措施，就是你在养殖场抗药性高于平均水平或者高于这个规定的抗药性水平，那么我们就给你一个黄牌，给你一个整改的机会，对吧？那么他就逼迫他们养殖场呢自己来想办法来减少抗生素使用，来降低抗药性，主动来找这个检测部门来检测。我们要做抗体检测非常麻烦的，他没人愿意让你检，对吧？再一个呢，对兽医，你只开处方和养殖场和这个兽药厂都没有关系。以后呢，兽药它给你加税，这样的话，抗生素使用呢就没有驱动力了，对吧？另外呢，他提出 One Health 这个概念，就是人医和兽医它是一个整体的，所以通过这个措施呢，很好的把抗药性给降低下来，压制住。那么我们国家呢，在技术目标、技术措施、一些这个标准体系，也包括这管理创新方面，还有很大的这个提升的空间。那么面对现在呢，我们人城市化了，非常密集，养殖业也集约化了，也非常密集，而且我们这个交通物流呢也非常发达，就流通也非常广，所以呢，病原微生物面临一个前所未有的这样一个空间，对吧？一个生态空间，所以呢，我就有感触，就很难想象呢，在高速公路上，奔驰的这个宝马，它不需要导航，因为太快了，太多了，对吧？也很难想象现代战争呢，可以没有这个东风导弹，对吧？你没有精准打击，也就是说呢，很难想象在现代医疗中可以没有流行病学监测和噬菌体这样一种活体的智能化的药物。 对吧？我们需要是指哪打哪的这种体系，而不是说呢我们打哪指哪啊。为此呢，我们建立了这个把抗药性监测与细菌体防控呢把耦合起来，建立一个协同的一个平台，建立了这样一些药品实验合作实验室和这个细菌体合作的这种研发实验室以及生产基地。自己呢研制了一个高通量的药物检测仪和细菌体筛选仪，这样的话就可以高效率的来完成检测，并且对监测结果呢，我们提出了一个综合的抗性拉指数来评估。那么我们建立兽医抗性监测网的 WAMS 呢，现在有2万多株这个动物园病原菌，它从这时空菌药畜几个线索来这个整合了这个抗药性流行病学的这样一些数据和一些菌株细菌体。通过这个大的平台呢，我们可以呢选择某些区域、某种动物、某一个时间段对哪种病原菌、哪几种抗生素它的 MRC 频率分布，可以统计出拉指数来评估它的抗药性水平。同时呢，我们人医和兽医呢，给疾控中心，也包括我们省立医院和国家疾控中心，在人医方面、在兽医方面呢，我们建立一个这个山东省的一个抗药性与防控监测网，也包括国家的一个这个抗药性监测网。这样呢，就可以把这一系列的实体的资源、数据资源，对吧？和这治疗资源把它整合起来，来协同来防控超级细菌。那么 WAMS 监测网，这是我们这10年对于大肠杆菌这个抗性监测数据非常庞杂的 MRC 频率分布图。那么这个图呢，我们可以通过拉指数呢来整合成一个数字，对吧？这个具体的方法我就不讲了。那么我们这个不同领域，这个肉鸡，这个不用抗生素养殖的肉鸡，医院的病人，我们再和欧盟实验药品委员会来比较，完全不用抗生素 SPFG 比较，我们可以看到呢，有些抗生素它抗性拉指数呢还是比较低的，就在5以下。那么有些抗生素呢，它抗性拉指数非常高，所以呢，抗性也不是都一概的高，我们重点是针对高抗药性的这些抗生素来把抗性给它降下来。那么我们可以看到，兽医普通养殖的拉指数是8.22，那么医院呢才1.45，医院病人。所以呢，兽医就像这个抗药性就像一个悬河，它对这人医呢是造成了巨大威胁，不仅对医院，而且对饲养员、兽医和屠宰工人直接接触动物的这些人员呢，也造成巨大威胁。那么我们兽医是8.2，人医是1.45，那么我们完全不用抗生素，这连续3年不用抗生素，我们可以看到抗性降低了，但是也没有完全降到人医的水平。这是因为什么？因为饲养员你总得带菌吧？那么你买的鸡苗，对吧？你并不是说抗性那么低的，对吧？再有的抗性机制，即便你不用抗生素，它还是容易携带，不容易降低下来。所以我们横的一刀不行，我们就用新的技术方法，竖的一刀，比如细菌体，对吧？所以呢，我们5到10年的这样一个主要目标呢，就是把抗性降到1.5或者以下，对吧？这样呢，我们才算说我们健康，我们国家防控超级细菌达到了一个这个较高的水平。那么实际上呢，防控超级细菌呢，我们还是要有一个生态的这样的思维。超级细菌它不是一个细菌，它是一个流行菌株群。对于这个群呢，我们也有一个群的防控的一个概念，一个用多种技术方法，它也是四面楚歌，不要单纯依赖抗生素。我们用中药、微生态制剂和疫苗来做一个基础的保健。再一个呢，用抗生素和噬菌体，它这种治疗性的、攻击性的这种技术和产品来协同抗菌，对吧？那么对于这个流行菌株群呢，我们也是每一种药物呢，也都需要一个群来这个抑制它。所以从管理上来讲，我们也是应该这样，对每一个群呢，锁定一种病原菌，比如大肠杆菌， 对吧？那么这各种药物的群我们也要建立起来。对噬菌体来讲是也很简单，我们可以筛选大量的这个裂解性噬菌体。那么这些噬菌体呢，只要说效价比较高，能够裂解这个区域的这些流行菌株，那么我们就可以认证嘛，作为新药来给它这个批准使用。所以说，它临床上怎么来组合它，那是根据这个流行菌株的这种变化来组合。那么抗药性的管理呢，就是这个噬菌体的这种管理策略呢，也是很容易制定的。那当然这是一个庞大的工程，涉及到一些法规，对吧？各个层面的这种执行，所以我们还是需要积累大量的数据和证据，来给这个主管部门的评审专家来参考、来决策。那么我们目前呢，已经分离了2万多株这个流行的病原菌，它有致病性、抗药性和流行性。那么筛选噬菌体呢，有1300多株。那么大肠沙门金普铜绿呢，这个分离最多，对吧？我们希望再有1年的时间，那么噬菌体的数量能翻番，能达到3000株。对于已有这些噬菌体呢，我们希望它更成体系化，不在于数量，而是说它能够对主要的这个，比如欧抗原、大肠杆菌，它能够对应起来。这样我们的库呢就非常简洁，非常有结构、有秩序，用起来就非常方便。那么对噬菌体比较小的呢，我们尽快把它充实。我们目前呢，只需要因为有高通量检测方法，只需要7天的时间就可以完成200份样品的这种采集、这个检测，对吧？药品实验、噬菌体筛选，也包括抗生素、噬菌体联合使用这样一个检测，这样能满足医院和养殖场的这样一个需要。那么药理学呢，首先呢要解决毒理的问题，就噬菌体安全性。我们首先要锁定人畜共患的流行菌株群，它有致病性、有抗药性、有流行性，锁定它，我们才能这个用它来筛选噬菌体，而不是用普通的一些没有致病性的菌株，比如普通大肠杆菌，那是没有意义的，甚至有危害的，对吧？那么筛选噬菌体呢，我们重点要筛选裂解性噬菌体，这样避免溶源性噬菌体携带抗性基因和独立基因整合到新的病原菌上，来扩散它的危害。那么我们用这个病原菌来筛选它的噬菌体，但是不能用这个病原菌来生产噬菌体，所以呢，我们要对这些菌株做些无害化的改造，敲除它的抗性基因、独立基因，对吧？这样保证生产和应用的安全。最后呢，在使用方面，我们要这个噬菌体和抗生素啊，怎么来协同组合？包括使用剂量、途径啊、频次、时机啊，对应的动物症状。那么这一系列我们组合起来，那么我们相信它安全性还是非常好的。那么噬菌体呢，它的药理学参数呢就有一定特殊性，对吧？你比如说它宿主谱一般它很小跨种裂解，但是我们可以用几种菌的噬菌体我们组合起来来做鸡尾酒疗法。第二个就裂解谱，就同一种菌里边几群不同的菌株，那么噬菌体能够裂解多小，就是它裂解谱。我们希望它裂解率呢能超过60%以上。再有这个噬菌体和病原菌它2个菌群相互作用，它有个阈值效应。我们一般人这个要求呢，病原菌呢不超过10的6次方，噬菌体不低于10的6次方，这就是双6原则。再一个呢，它的特点是残余的菌量，就它相互作用之后，它都有残余，它像抗生素、消毒剂还不一样，所以这个特点呢，也需要它一个其他的这个药物呢来和它协同来抑制这残留的菌株。但它好处是什么？残留的噬菌体会长期的跟踪这种残余的菌株。再一个呢，我们也通过不同攻毒剂量的实验，我们证明呢，你比如 SPFG，那么它的肝脏不管攻毒剂量多高，那么它大致的载菌量都在10的5次方到6次方这样一个 CFU 每毫升。那么因此它的噬菌体用药剂量呢 就在10的6次方到8次方。再一个，那么它残余的这个病原菌呢，它会重新长起来，就是抗性菌。那么这抗性菌它产生的时间，我们希望它越往后推迟越好。那么这个也是一个参数。再一个就是噬菌体它们两之间的协同裂解率怎么样？噬菌体和抗生素协同裂解怎么样？对吧？再一个，它协同之后，它可以在同样疗效下降低抗生素使用量，那么它这个降抗的指数怎么样？再一个就是噬菌体药代这个，那么需要对它宿主菌和噬菌体呢，比如做一些荧光标记啊，对吧？这样一些通过活体动物这种检测才能实现。那么这个也是我们后边要做的工作。那么对于单一的噬菌体呢，它呢随着噬菌体的剂量这个增加呢，它的抑菌曲线我们知道它会逐渐压低，对吧？但是呢，我们也可以看到，就是在这个15、16个小时以后呢，它的这个抑菌曲线，就是参与的细菌呢，它又重新长起来。所以这是单一噬菌体这个抗菌的一个重要特点，我们就要想办法把它压制住。所以呢，需要噬菌体来协同，噬菌体和抗生素来协同。那么噬菌体协同呢，我们可以看到这两噬菌体这个组合起来，我们看它抑菌曲线，有的呢抑制效果并不是太强，但有的呢，它的抑制效果就比较好，就是很好的这个协同抗菌组合。那么噬菌体和抗生素呢联合使用呢，也有这样的效果，就是单一的 A 诺萨星它就曲线这样，对吧？ MRC 呢是8微克每毫升，但是用了噬菌体之后，加了噬菌体，我们可以看到整体 MRC 呢降低，整体给压低了，而且它这个 A 诺萨星的 MRC 呢可以降低到2微克每毫升，那就可以减少抗生素使用了，对吧？表观的 MRC 呢降低了，就是它的抗药性呢表观抗性降低了，对吧？那么浓度杀菌曲线也可以看出，对吧？伊诺沙星它本身是这样一个杀菌曲线，那么加了噬菌体之后呢，它用量呢也可以显著降低。那么这种协同的噬菌体这个鸡尾酒呢，和不同的抗生素我们结合使用，也可以看到，你比如说富比尼考、多烯环素、这个安普明素，对吧？那么它的使用量呢，也可以大幅度降低，可以降低到1/8、1/4。那么这就是可以达到了减少抗生素使用和降低抗药性这样的效果。那么抗生素和噬菌体先后使用也可以起到这样的作用，就是比如说头类假大孢菌，我们用噬菌体先处理之后，那么残余的细菌怎么样呢？我们把它重新这个培养起来，让它恢复正常生长。我们可以检测发现它的 MRC 这个蓝色的要比原来呢都有显著的降低，对吧？这就起到了健康作用。那么进铺菌呢也存在这样一个趋势，对吧？所以呢，这是后边这个属于这个性价比比较高的这个研究工作。那么我们举一个实例，就是千湖这个集团公司，它是一个每年出栏的6000多万只肉鸡的这样的企业。我们去年9月份给它做了检测，采集了60份病料，分出了43株大肠杆菌，和19株萨米斯菌。那么噬菌体的组合裂解率都能达到100%，它抗性拉指数呢是14.55，对吧？随后呢，我们又对给它供应鸡苗的这些企业呢，来做了一些检测，分离出6种病原菌来，对吧？主要是肠球菌和大肠杆菌。那么大肠杆菌的抗性拉指数呢是这个9.17，它要比商品鸡要低，这说明鸡苗呢它要比这个养殖场呢它抗性还要好一些。就养殖环节是降抗的重点。那么噬菌体的这种协同抗菌率呢，大肠杆菌也能接近80%，萨米斯菌100%。今年3月份呢，我们又给它做了一次集中检测，可以看到它的鸡苗这块还是6种病原菌，但是种类有所变化，沙门、肠球和大肠是主要的，对吧？那么它抗药性拉指数呢，我们用了1年之后可以看到呢，它的鸡苗呢降低了5.06， 但是它商品基呢提高了，为什么呢？因为它头孢赛夫它的蜡质素大幅度升高了，拉高了这种蜡质素数值，所以千湖公司呢马上把这个头孢赛夫停用了。根据我们建议呢，它今年呢集中使用这个富贝尼考和新敏素这2种相对敏感的抗生素，对吧？那么大肠杆菌噬菌体裂解率呢，综合裂解率是72.7%，那么也有很好的效果，对吧？所以我们就期望呢，经过1年之后呢，我们看这个千湖的抗药性情况怎么样。那么除了这些药理学指标呢，噬菌体的还有一个重要的选择要素呢，就是第一个效价要高，第二个它要耐热，要不耐热的话，这冷链运输啊非常麻烦，成本很高的。第三个就是这个要建立基因编辑的这样的平台，对噬菌体做改造，这样的话使它的裂解谱呢更加可控。我们最近一个非常好的例子就是这个研制出一个嗜热的广谱的萨米氏菌噬菌体饲料添加剂。那么它可以在85度下1个小时，它效价仅降低了1个数量级，对吧？它能裂解这个萨米氏菌主要的这血清性、广谱性，对吧？我们经过这个高温高压这个就是85度3分钟这样高温高压智力实验之后，这个检测饲料里边每一克饲料还有10万个噬菌体。这个呢，对于我们解决噬菌体净化这样一个这个世界性难题呢，有可能给出一个新的选项。那么噬菌体应用呢方向也比较多。那么根据它的特异性裂解的这种特点，我们可以做一些诊断试剂盒来诊断病原菌，也可以用它治疗特点来做这个养殖或者人医临床的这种治疗，也可以作为饲料的这添加剂，对吧？也可以用它裂解酶来直接来治疗，或者用它噬菌体展示技术呢来展示这个其他的抗菌肽啊，或者噬菌体裂解酶，或者动物的病毒抗原来做成噬菌体疫苗，对吧？再一个呢，我们也可以用噬菌体来遇到非特异性免疫，来这个抑制动物病毒的这种感染。对于溶源性噬菌体呢，我们也可以诱导出来使病原菌的致病力呢、抗药性呢来降低，就弱化它的致病性。另一个呢，诱导出来就是溶源性噬菌体呢，我们可以通过基因编辑来改造成裂解性噬菌体，通过这些技术手段呢，我们给一些大型的养殖集团公司呢建立一个长期的合作，对吧？来这个反馈检测的结果和这个防控的效果，对吧？来持续改进。那么也建立了噬菌体和病原菌这个它的分离流程、建库，也包括对于临床的分离的菌株呢，我们高通量来筛选噬菌体，高通量药品实验来评估，对吧？来筛选协同组合，对吧？来把它这个通过发酵、小罐发酵、定制、超滤来给兽医和人医来提供，对吧？这样一个非常快速简洁的这样一个流程。同时呢，我们建立协同抗菌药理学联合实验室，来这个开放合作，一起来推进这噬菌体的这种药理学这种研究和应用。我们出版了2本书，这个噬菌体药理学及实验方法，来供大家参考，对吧？也请大家多多批评指正，我们共同来完善噬菌体药理学。那么一个利好的消息呢，就是这个第13届人大代表呢，这2位代表有个提案，就是加快噬菌体在农牧产业应用体系的建设，这个也得到农业部兽医局也肯定性答复，对吧？也鼓励我们呢，这个鼓励和支持我们研发抗生素替代技术和产品，这样在国际竞争中呢立于不败之地，这个抢占一个先机和资源。最后呢，也感谢我的团队同事和同学们的这种协同努力，感谢各类各级科研项目的支持。我们呢从16年开始连续举办了5届齐鲁国际讲堂， 和1届这个公共卫生云讲堂，也得到了国内外的专家和企业家的这个积极的这种支持啊，这个参与和奉献，在此呢表示深深的感谢。最后呢，让我们一起来这个致力于公共卫生。像公共卫生的核心呢，就是公众共同来维护生命、保卫生态，让我们一起努力。谢谢大家。
Well, thank you so much, and I'm really sorry we ran way over time. And if there is any questions, please go ahead and for everybody online, go ahead and use the Q&A function or provide it to myself or email me on the chat, and I will make sure to forward it to Dr. Yu Chen. But as of right now, we ran out of time, so I would like us to get your attention and introduce you to Dr. Awani Pech Kwang Kwai, and I hope I said the name right. And Dr. Awani, she's currently is a lecturer at the School of Science and Technology for Semastat University in Thailand. Just a brief description. She will be much better than me, of course, as I always say that. She's going to introduce us to a very valuable joint research center. It's actually labeled abbreviation-wise IJC-FoodSec, which is a new international joint research center on food security for Oceania region. And as everybody aware, food security is becoming a very critical thing in our days. So we're going to be very excited to hear about it. I'm not going to go into more detail of what IJC FoodSec is. We'll leave that to Dr. Awani. But I would like to bring the fact that Dr. Awani is a co-founder of this great collaboration center. Dr. Awani, as I mentioned, she is currently lectures at the School of Food Science and Technology, Faculty of Science and Technology at Semastat University in the Rangjet campus. And actually, she graduated with a degree in food technology and also a degree in Ingemerate microbiome in Zamik. From Sorani University and in combination with INSTEP Toulouse, France. We really appreciate your experience that you're going to share with us, and please go ahead. Thank you.
Thank you, Professor Joseph Flair. Sorry if I pronounce your surname is wrong. Okay. So thank you for your introduction, and good morning, Chairman. Good morning to all participants in CIFSQ in China. And also good morning and say hi to everybody around the world that you are watching this online conference. So I am Awanvi Pech Kwang Kwai. So right now, today, I'm going to give you like a new information about our new Joint Research Center on Security. So let me share my slide.
Yes, we can see it. Go ahead. Thank you.
Yes, thank you. So the International Joint Research Center on Food Security, so it was officially launched on the 8th of July this year. So we just launched this Joint Research Center like a few months ago, and the Minister of the Science and Technology and Research Innovation, so he is come to our grand opening ceremony, and he initiated this Joint Research Center. And the Joint Research Center is like a, how can I say, it's like a combination of a lot of consortium that work together. So this Joint Research Center will work and collaborate with the Queen University Belfast in UK and also with Thammasat University, especially my university, and also the National Center for Genetics and Engineering. So 3 partners work together and become like we form this consortium and we form this International Joint Research Center. And the Minister of the Science and Technology, he agreed with the concept that in the next few years or maybe in the next decade, the food security is an important problem and important issue in the Southeast Asia region. So that's why we try to develop and form this consortium, and finally we can launch it like a few months ago. So before going into the depth detail, I would like to show you about the video, like a short video presentation about the International Joint Research Center, so that you can see what's about the history of the International Joint Research Center and also what we are doing at the moment. So do you see my video? Do you see my video?
No, we don't
No.
see that.
Now we do. Now it's starting.
Okay.
Food security involves access to safe, nutritious, and sufficient food. Effective food control systems are essential to protect the health and safety of consumers. NSDA has initiated the Food Innovation Program focusing on enhancing the competitiveness of Thai food industry. The program covers the development of technologies, processes, and products to add value to local materials. The International Joint Research Center is an important puzzle piece to address not only national but global challenges, especially the integrity of our food system.
Our consortium was formed through collaboration. I've worked for a long time with biotech here in Thailand, more than 10 years, and it's been very, very successful. Over the past few years, I've also worked very successfully with Thammasat University, and we had the discussion, why would we not all want to come together and form a new research centre? So this is the start of things, and we just think this is the start, and it's just going to get bigger and bigger.
We have to solve the problem of food security within this region using our knowledge, novel knowledge on diagnostic, on mass spectrometry and mycotoxin. We are going to try to fully utilize the capacity from different consortium member, let it be different research laboratories at IGFS in Queen University Belfast, the facility in STDA, Biotech, MTech, NECTech, Nanotech, as well as Thammasat University. Together, we believe all this facility will create a bigger impact for food security by using mobility schemes, exchange of staff, exchange of students, exchange of our expertise to address these food security problems. The last one is for technology transfer from our joint research center to the company that really interests our novel technology or platform.
Serving Thailand's societal needs has been Thammasat University's guiding principle throughout our history. It is our great opportunity to collaborate with Biotech and Queen's University Belfast on this research center.
Okay, thank you so much for watching the video. That is a summary video, like all a VTR of the IJC FoodSec. So I think all of you know like the history of the IJC FoodSec, why we become together. And from now, I will tell you about the vision and the mission and what the project that we are doing it right now. So I will stop sharing this video and I will go back to my presentation. So as I mentioned earlier, the IJC FoodSec has official launch in July, and by the Minister of the Science and Technology. So it is like our honor that he come and he give like a grand opening speech for the International Joint Research Center. So the history is as you see in the video, that this is like a 3 universities, 3 institutes. We work together for a long time, like more than 10 years. So we have like a close work between Queen University Belfast, which is the #1 UK university in food science and technology, and also in agriculture. And I work closely with biotech for a long time. So that's the reason why 3 institutes become and join and form this International Joint Research Center. So our vision is to undertake the world-class research in the world-class facility. I will show you later on what's our facility. And for this, just for support the food security in the ASEAN region. So not for only ASEAN region, we try to cover all the global challenges as well. For the mission, so we are trying to increase innovation to our multidisciplinary, because inside our IJC FoodSec, we have like a lot of the researchers who expertise in different areas. For example, organic chemistry, about the IT, and also with the system. We also have the researcher who specialize in microbiome, in metabolomic, and also with the next generation sequencing. And we try to use all those research expertise of our researcher to solve the problem in the food security challenges. We also trying to facilitate technology and expert transfer among the consortium partner and stakeholder. And we are trying to give like a training for a future researcher to address like global food security concern. And then we are trying to increase our public and international visibility as well. So this is the vision and mission of the IFC food sector. So why the food security is become like an important problem or a big challenges in during this world, because of we have a growing like a huge number of growing of world population, and we thought that the expected number that the world population in 2050 is going to reach around 9 billion. And because of climate change and because of the complexity of food system, so they're gonna, all these factors will gonna produce like a food security problems. And we must produce more foods over the next 50 years, because we have like an increasing number of the world population increase, and all the people should have to get and to access to the safe food. So that's the reason why more food is, we have to produce more food, and that should be safe as well to provide to our population. And currently 1/3 of the world population live in the country where isn't enough water and its quality has been compromised. So maybe in the next like 5 years, so we need to change or maybe to solve the problem about water, and this is going to be expected to rise to 2/3. So as you see that we have like a lot of the food security problem, and we have also like a food system that is very complexity. So IJC Food Sec try to work maybe in just like one or two key area that we are doing it right now. So I will tell you later what the project that we are doing at the moment, but for this I am going to show you about the research facility. We do have the innovative diagnostic development facility, for example, microarray. We have microarray fabrication technology. We do have microarray technology platform. We do have the metabolomic facility. We have the analytical instrumental for food security, for example, LC-MS-MS, GC-MS-MS, GCO, and another sample preparation facility. You can see it in the video. And also we do have the gastrointestinal simulation facility. So this is the team and tiny team that we're gonna use for study about the gut microbiome, the interaction between gut microbiome and the maybe some toxic substance or maybe some probiotic in our digestive system. So this is like this instrument is the one instrument in Asia that we have it right with us right now. So this is all the innovative diagnostics. So this is for microarray platform and microarray fabrication, and also metabolomic facility. As all the instrumental for food security that we use in our laboratory, that we use in our joint research center. Or the sample preparation here, facility here. And also this is the gastrointestinal simulation facility that I said before. So this is the only one technology or only one instrument that we have in Asia. So this one, so this is gonna represent our digestive system. So we can adjust everything via the computer, use the program, and then we can adjust it. So the system can simulate like our stomach, our intestinal, and our large intestine. So this is the thing and the instrument that we think that is gonna be help solving the problem of the food security in the next future. And what about the research that we are going to do? Actually, at this moment, at this stage, we do like the research on food quality, food safety, and also food authenticity. The example is we are doing a lot of research in mycotoxins, in chim, in rice, and maybe some food feed additive. And also we also develop a point of care devices as well. So for the mycotoxin, you know that in the past, like in the last decade, the FAO estimate that the mycotoxin was contaminated with like a 20% of the agricultural community. But our team of Professor Chris Elliott and also with Professor Rudolf Kruska, they tried to estimate, and they found that the new number is that currently, because of climate change, the mycotoxin can be contaminated into our agricultural community, not 25%, but it's going to be 60 to 80% at the moment. So please be aware that 60 or 80% of your agricultural community may mostly contaminated with mycotoxins. And the mycotoxins is quite dangerous to your health, because most of them can cause like a cancer and maybe interrupt into your maybe immune system as well. So that's the reason why IJC FoodSec try to develop like a research on in order to solving this problem, and this is going to be our big challenges. So the project that we work on mycotoxin is comprised of the 7 work packages, and that cover from upstream to downstream. For upstream is about the climate change and fungal contamination. So we have a researcher who expert in working in the farm, trying to develop like a greenhouse, and then like a farm, and then apply it in the field. So that this is the work package number 1. For work package number 2, we try to detect mycotoxin contamination and also emerging mycotoxin contamination in our food, in our agricultural commodity. And then we try to find a method to reduce the mycotoxin level in the food and feed. And the work package number 4 is about the point of care detection platform. We try to develop a platform that very easy to use, portable, handy, that we can like detect in the farm very rapidly and directly without bringing on the sample back to the lab and then wait for 1 day or 2 days. We won't do that, but we try to develop it on site detection. And then we have also work package number 5 for biomonitoring and biomarker analysis. This is just want to know that what is the mycotoxin contamination level in human body. And then we try to do some capacity building. We try to send and have like some exchange. We send the student to around the world to our partner and to do some training, especially in mycotoxin detection. And we also do have like some workshop, and also with the science, we submit a lot of the scientific review article into Q1 journal as well. That is the way that we try to publish our work. And for the CHIM, this is the project that we got funding from EU. And this is like a lot of consortium of EU that join into this project as well. So we do like a CHIM genomic and also CHIM gut microbiome. So we try to make like to produce a safe CHIM or safe aqua to all food consumer. And also we do some food authenticity about the rice samples, about the chemical fingerprints, and to see the rice quality and the rice safety. So this is for the authenticity of Thai rice. So we have the team, we have the expert who work on that, and we have also a world-class instrument for working on this as well. So from this research, we can find like a chemical fingerprinting of the Thai jasmine rice. So that is very useful for food authenticity. And also we also develop innovative diagnostic for food security. So at the moment, we are trying to develop a dye here. This is very novel dye. That is fluorescence. And we can apply this for mycotoxin detection and also with the heavy metal, with pesticides. That is a project that we are running at the moment. And this is the organization chart. So Professor Chris Arias, he is the International Advisory Board. So he is the main person who mentor and help us to guide and shape the IJC food safe. I myself and Dr. Nisara, we are co-directors. So I am from Thammasat and Dr. Nisara from NSTDA. So we work together, we co-direct the IJC food safe together. And this is our research member. They are really good, really excellent, and they are expert in several fields. And this is our national collaboration at the moment. We have a collaboration within Thailand that is from Mahidol University. This is for Faculty of Medicine. So if we want to do like some research or some project that related to humans, so Mahidol University can help us for this. And from Thammasat University, from Silpakorn University. So this is really good in dye development and biosensor development. And Kasetsat University, Chulalongkorn on biosensor, and Prince of Songkla in risk assessments. We also have the international research collaboration that is from United Kingdom, from Queen University Belfast, from Belgium, from Italy, from France, and from Austria, and also from China. That Professor Yuning Wu, he is really help us to shape up and to solve the problem of the food security in Southeast Asia region. So actually, we will not stop. We will not stop for all these partner, but we are going to expand our network to our partner from the industry and also from the another university abroad as well. So if you want to collaborate with us, if you want to work with us, we are always welcome to have you to join into our joint research center. So you can visit us via this website, or maybe you can send email to me or send email to Dr. Nitsara, who she is the co-director of the Joint Research Center. So thank you very much for your kind attention. So if you have any question, you can ask me about the IJC food sec. Thank you.
Thank you so much. It's a great collaboration between biotech, the Queen University, Thammasat University.
Yes.
Great work. Also, my compliment to your work in food security itself. Just I failed to mention, you are probably one of very few experts in mycotoxin, and this is a whole next topic for mycotoxin. But your work on that to try and eliminate this issue, especially in Thailand, I'm very familiar with that because I am also a customer of a lot of suppliers from Thailand. So I am very impressed with that. And definitely, Professor Elliott, I got the opportunity to meet him in person. Wonderful, great experience. Yeah. My biggest suggestion to you, actually, to grow this, you need to expand your advisory board, and you need to look at it from industry, from other entities, World Health Organization, you know, a lot of this, so you can add a little bit more to it. But I will be an advocate for you personally.
Thank you.
Any questions, if anybody in the room have any questions, or if anybody online, you can use the Q&A function. Anybody have any questions? Let's give it 1 second. Okay, I have one quick question and then we'll let everybody go on break. And thank you for your patience, by the way. Dr. Yushin, before you also was very interesting topic too for the felon. So beside the research you were saying, is there any other research you're working on as far as the center?
Yes, so apart from mycotoxin, apart from chimp project, apart from rice project, so currently we are trying to expand our research in food security, for example, like heavy metal detection, pesticide detection, and microplastic detection. That is the thing that we are going to do in the next few months. And also we are trying to see the drawback of the alternative protein, for example, like allergen, mycotoxins. That is like a limitation, because all of you may work a lot on alternative protein, but you should like think about the drawback and the limitation of alternative protein as well. That is the project that we are going to do it. Yes.
I will be following up with you on that personally.
Yeah, thank you. Thank you.
We have a very big alternate protein line under the Gardein plant. Thank you so much. Oh, there's one question really quick. I know it's time for break, but let me see. Mr. Kerry's son has a question for you. He said, why is it called food security and not food safety? I think you can answer this. They're all combined together. Good.
Yes, because actually we are thinking like the security is more important. We are trying to develop like a food that's safe, and a lot of most of the people should like get like the safe food, and maybe we have to secure that we can produce like a food that enough for the people in the future as well. So we try to use it like a security, and we cover in a lot of area of food security. Yes, but it's just the beginning. Maybe you can see it's maybe it should be safety, but in the future it will be more security in food security. Yes,
the food has to be safe in order to achieve food security, because if it's not safe, it's going to get dumped and go to waste. You know, that's, or get somebody hurt. But thank you so much. I know we're a little bit behind time, but I think no, actually, we're going to take a short break, and we will be back at, let me make sure the timing wise, at 10:30 Shanghai time. Okay. Thank you so much. Thank you. Pleasure meeting you too. Thank you. We're going to start. So just for anybody in the room, is Dr. Ken Wang there in person?
Hi, Joseph.
How are you? I guess I would like you to introduce yourself, but we have Dr. Guo Miao. She's joining us virtually. I'm gonna introduce her, and also if you won't mind, Dr. Wang, if you would introduce yourself after I introduce Dr. Miao. We're gonna have a very interesting presentation here about a very important subject. It's going to be an introduction on food safety management framework for recycled PET used as food contact material, which is very important with the number of millions of PET bottles goes everywhere. I'm guilty of it myself right there. So just to move forward, I would like to introduce Dr. Miao. She's Pepsico Food Safety Associate Director for the APAC Center, for the Food Safety Center of Excellence. She's based in Beijing, and her responsibility is ensuring food safety design, food safety compliance, and capability built across China, Asia, actually, China, Australia, and New Zealand. wonderful experience with many years of industry experience for the manufacturing of safe beverage and food, of course. She's an established scientist in food safety and food microbiology, and also all the quantitative and data-based risk management too. She was over 35 food microbiology and biomedical publication, very impressive. And Dr. Miao, she holds a PhD in food science from the University of Maryland, College Park in the US. And let's move forward and go ahead and let's start the presentation. I'm very excited to hear about it personally. So.
Thanks, Dr. Joseph.
Yeah.
Thanks again for the invitation, and it's great honor to be one of the speaker in your session again. I believe I was the speaker in the 2020 session.
Yes, I remember.
So
hopefully next year we all meet in Beijing. I hope.
I hope the same, but again, due to some of the still COVID restriction domestically in China, unfortunately, I will not be able to join to deliver this session in person. But I think I'm gonna be here in Zoom, and my Ken Wang, which is also from PepsiCo Food Safety, gonna be physically presenting this meeting and give you
Wonderful.
like overview about that. I think he's gonna deliver this in Mandarin. So I hope you got lots of great information from this presentation. So with that, thanks, Dr. Joseph, and I will pass to Ken.
Okay, so thank you, Joseph, and thank you, Dr. Guo. So I'm going to speak in Chinese. 大家上午好。
So, ladies and gentlemen, dear colleagues, good morning. First, I want to thank the material organizer for inviting Pepsi team and to do the speech here. So today, my topic is the recycled PETs, the food contact materials introduction for the food safety management framework. And this material was prepared by Pepsi, the whole team, and also the Suchat and the Perry, and also Dr. Guo and me, and other the team members that jointly make this material.
Sorry, next slide. Next slide. 下一页。doesn't work， 不行。OK， 那在接下来的这个半个小时呢，我会给大家从
The following 30 minutes, there were 3 parts of my presentation. The first is the recycled PET, and then the food safety evaluation method for the PET, and then the food safety management mechanism. There are 3 parts of that. But first, we will see why we should focus on that, but take action on the PET, because now plastic wastage and also contamination has become worldwide issues. But about now, the only 9% of them that can be recycled every day. It's about 1 million plastic bottles become the waste, which will cost the actually every year out to the so 380 billion bottles will be landfilled. So the contamination of the plastic caused by the human beings. So for the human, we should provide a solution to resolve the problem. For the plastic contaminations, they obviously can see in the river, in the ocean, it draws a lot of attention. But as we can see from the chart, from the media like New York Times, and reported that those big plastic bag without that's 8.3 the million tons. Million tons of wastage in the ocean, but if we resolve that, the problems that maybe the weight of the plastic waste could surpass the total fish weight. But that's why we should focus more on these sustainable packages. And for example, take it with California state of US examples, but then the state government, but they still place that about the so for the manufacturers that should be used with at least 20% of the recycled materials by 2030, and the ratio should be increased to up to 50%. Also, some of the enterprises, but you see the many big companies that focus a lot on the recycled packages. And but from perspective of the food industries, but we work very hard on the on that. When we think of it from the three dimensions to reduce, recycle, reuse, and therefore reduce out the issues to often those garbage, plastic garbage, pollution things. About the first evolution of design by the 100% recyclable materials, and then we should maximize the way to offer the reusable materials. The third part is to be invested on those installation of the recycling facilities, and also to increase the consumers' awareness, and also to increase the influence on the publicity, then to involve more people in participating in this. The action, I think about used to be in the keynote, and the general manager of Mr. Liu from Pepsi Asia Pacific Research, and they made the great points, but tell us about the so what about those how Pepsi work very hard on the agriculture and the value chain and the products, and by 2025 they talk about Pepsi global will realize 100% of the recyclable the materials to reuse those recyclable materials, and therefore to further increase, but now we're talking is to further increase the recyclable materials utilization, and then to encourage the consumers to use more the recyclable materials. And by 2030, and we try to reduce the utilization of the primary plastic by 50%. And we start to further using the use the recyclable plastic as well. So the China has the two targets for one's carbon neutral, carbon peak, and then they are to respond that. So we Pepsi will set up our but the carbon target. And from China, maybe the small you'll see it. If we include this if we make a comparison of the parameter of plastic, PET bottles, and recyclable PET ones, but I think for the recycled ones, and has the obvious reduction of the carbon emission. And also, it can be the further the bio degradable to use for the other plastic products. Then the speaking of this, there were three main recycling methods. The first one is industrial recycling. It means that to collecting the leftover materials from the process of the raw materials, and then maybe some of the leftover from the extrusion or the injection molding. But this is before the consumer, before consumer consume this. But usually it will bring negative effect on the consumers. The second one is the physical method of recycling, and that means that after using the PET bottles, when we that we need to collect by the physical method, and to collect them, then we use the physical method to further process, remanufacture that, and we should clean, cut, and the decomposition of all the melting and the particle manufacturing, but therefore to form the PET particle again, and to make it reused by the materials. And the third method is the chemical method. That's also the towards those used the PET bottles, use the chemical method is very good for those PET bottles, which is difficult to use the physical method, but like those minimal combinations with reconstitution of those the materials, and but it can achieve the same quality as the primary the PET bottles. But the cost of it a bit higher. From the chart, we can see we made a comparison of the difference among these three recycling methods, as from the production of the consumption of the whole of the cycle. So how does it look like? Even for the physical ones, the weight, but the weight of physical method is used for the beverage bottles, but there are higher requirements, but because for the beverage bottle, it needs transparent, plain bottles, so it's difficult. So so if you use the physical method, the requirements are higher. If you use the chemical the method, then there's less requirements on the use of the PET the bottles. It doesn't require it should be full level. Then it could be the widely used the wider applied in the future. Then in terms of the physical method of to recycle PET, which have become you see, then back to the chemical method is more complicated, and the cost is more is higher. Then let's focus on the physical method of the recycling on the PET, since for recycling, and then the cleaner, and the cleaner will collect those garbage or from the those the garbage collection point, then they collect water by PET bottles, and then later on to make the sorting off, and package them, and then transfer them into the collecting the point pump. And later on, for those the recyclable plastic into clean up and also pull off the tags, they cut, and then melting and decontaminates, and then later on to make reuse the recyclable PET. If it is used for full level, and we need to evaluate evaluate this risk of food, the food safety risk from the start between the end. There were two references for that. This year in February, the UN and the FAO have made a report, but a report mentions that when using the primary plastic or the recyclable PET, or even if used in the hazardous way, it may be involved with the chemical hazards. Anyway, so for somebody with the hazard may transfer them to the beverage bottles. Then according to the FDA of 2021, but when using the chemical method or the chemical method to recycle the PET bottles, then actually with the after the collecting the contaminants existed in the polymer, the residual is low. Then that's why there's a very much less the exposure risk for by the consumers. But there is still some of the trace amount of the chemical contaminant as a small part of the packages. Well, it may migrate. It may migrate to the food or the beverages. So the consumers of these circumstances, consumer may the long-term exposure to such a specific contamination. That's why we need to have seriously monitoring on that. And for the this for US FDA and the EU FSA and towards the recycle of the PET and what was acceptable by these two the union for many years when they set up those law and regulations when I just recorded some of the part of that. They are to ensure the safety of the consumers when using recyclable the PETs, but then we need to make a risk assessment for the FDA, and if they this is the voluntary return check, but for EU FSA, but this is compulsory, mandatory the evaluations towards the member states of the EU to member the US or the EU. This is based on the challenge test.
And such challenge test is the core of the risk assessment. So after confirming the assessment, FDA and EFSA will issue letter of no objection and scientific opinion letter. Such LNO issued by FDA will be recognized by the regulatory bodies from other countries like Japan and Australia as the food contact material. IFSA requested that if such recycled PET used as food contact material, then at least 95% of the recycled material should be food level. And the regulation from FDA stated that all the PET resin material should be food level, no matter whether it's used for food contact material or not. So here is the samples of the US FDA LNO and the EU IFSA SOL. It's very vague, but you can tell that the LNO thoroughly explain and display the utilization scope. It stated clearly the final result could only be utilized by specific and limited, for example, the fruit with shells and eggs with shells, for example. And the storage timing should be a certain period of time, and the temperature should be a certain range. As mentioned previously, when using the recycled PET as food contact material, the challenge test is really important, because only after the challenge test to prove it's food safe, there could be 3 steps. First is to sample the raw material, the preliminary material, and contaminate with known amount of specific material. We can also alternate it by certain chemical materials and process it. The relative techniques and parameters should be monitored and controlled in such process. And after the processing, the sample will be tested for the residue of specific material to determine the amount, and the change of the volume will be considered as the treatment capacity of the process. So after the challenge, it could be determined that the scope and the utilization will be determined. So Pepsi, apart from the challenge test, we also use the mathematical calculation model to determine the contamination level, which we'll share later. So for the determination assessments, what should be the standard? The largest acceptable level and the concentration level should be determined by the migration analysis of the chemical contaminant in the recycled PET. First, there is one reference based on the guidance of FDA, that is, when using the recycled PET as food contact material through migration into the food, the maximum acceptable level is 10 ppb in food. So if we know the existing standard is at 10 ppb, then we can go reverse, analyze the migration, and determine the maximum acceptable level. So when it comes to migration analyze, so the migration side, the chemical analyze, the molecular testing, the recycling, the characteristic of it should be determined. So during the process of challenge test, we select a series of alternative pollutants recommended by FDA. So when choosing the contaminant, we know that there could be a variety of potential contaminant chemical for PET. Those chemicals could be characterized on different levels. We are listing different series of chemicals. We choose certain chemicals for respiration and the non-polar chemicals. For example, we choose chemicals with such characters like toluene. You can also check the list on our website. And then we determine the maximum residue content from FDA and the primary contaminant concentrate from FDA, and then determine relative parameters. After confirming the relative concentrate percentage, and then the chemical pollutants, the residue volume, and then we can calculate the efficiency of the reduction. You can tell from the table. So that's what we have done based on the regulation from relative authorities. What we have been done, not only the challenge test, but also other models or tools we're using, for example, the mathematical diffusion model, the chemical pollutant migration formula, and the models. Henry's mode, Flake's mode, based on such models. Once chosen the model, we can tell the technology, the timing, the potential pollutant during the process at different concentration and different temperature, and the potential residue volume, the residue level. We are now using the toluene as the selected pollutant for the testing. The preliminary polluting concentrate, we chose the threshold recommended by FDA, and after pretreatment and the processing, like pre-drying, extrusion, and crystallizing, step by step, the accumulated and the final residue volume, if it's below 6.7 ppm, which is acceptable by FDA standard, then it is acceptable. And the two differences differentiated based on temperature conditions. For risk assessment is to core to ensure the food safety management. However, that's not the only job to do. We should establish a comprehensive and systematic management system. This is what we're doing as Pepsi for the management control. As a pyramid, at the top is the food safety policies, and the second layer is the standard for recycled PET for food safety, and the third layer is the SOP guidance, documentation, checklist, instruments, for operation. And then we archive and document the checklist and assess the list of risks and make sure all the checkpoints are went through and consistent for the checking.
对于法规各地法规监管
And
要求
we
一个统计的这样一个工具表，
establish
从而确保我们在三
the
期的这个使
tool
用是既满足
to
食品安全要求，同时也满足当地
calculate and document the local regulation and international international regulation. And the first work to do is to record. We record all the operation procedures and approvals. Last but not least is about the culture. The recycled PET requires the training for the staff and the awareness of the team. After establishing the food safety framework, it is important to define the role and responsibility of the food safety team. Their job is to assess the documentation, to assess the recycling technology, and the approval of the factories.
FDA 的这个
We're talking about the documentation and regulation like FDA LNO, IFSA-SOL, the DOC, the heavy metal claims, the TDS and MSDS and NIAS and COA. When it comes to the assessment of recycling techniques, it's about the utilization condition, the production categories, the process flow, the parameters, description, temperature orientation, pressure, particle size and shape, and the assessment of the mathematical model calculation. And the third part of the job is the approval of the factories. That is to assess whether the factory is conducting the requested procedure and to confirm and verify the parameter of the technology. Around the globe, Pepsi Group had been safely using recycled PET in different sectors of the markets. For example, in US markets, we are using 100% recycled PET for drinking water. And in US and British, we're using 100% recycled PET for beverage and water. In Vietnam market, we are using 100% of recycled PET for carbonized beverages. So the conclusion of our work is that recycled PET technology has its own contribution on easing the contamination and achieve the goal on carbon peaking and carbon neutralization. And for the management of recycled PET production, we should establish a thorough and comprehensive throughout the whole production chain. Thanks for paying attention to my lecture.
Hi, Joseph, back to you.
Thank you. Thank you so much. And I know we have one question online, but I want to ask also if anyone in the audience do have a question, raise your hand and they will get you the microphone. And while we're waiting here, if anybody online have a question, please use the Q&A function. And one question from Boucher. The specific question say regarding the recycling of PET for food contact use, is there any challenge in China? For example, regulation, raw material source, consumer awareness?
Well, okay, that's probably a regulation question. Well, I'll try my best to answer that from technical perspective. So, well, I guess the the major challenge of applying recycled PET in China is due to the I guess it's due to the concern of residual chemical contaminants, because you see the chemical contaminants mainly for recycled PET mainly come from the post-consumer. So consumer can use the PET to store the other chemical. In China, it's a very difficult. So we have to figure out to have a chemical contaminant investigation to figure out what would be the most or the main contaminant for the recycled PET in China. And then as long as we have a fully understanding about this chemical contaminant, and then that would be give the confidence to the government, so they could see that we have done a very fully risk assessment on that, and we think that current the recycled PET and certain control measure can be safe for consumer. So I guess the major concern is we are very we needed to have more investigation and to have more confidence. The government needed to have more data or more research, more investigation on that, so to have enough confidence to have a certain kind of approval for our patent. Yeah, that's my understanding. I don't know if Dr. Gore, if you have other points.
So thank you, Ken. Again, I guess this is like a regulation-related questions, right? And I think, currently, basically, I think there's many, what I understood, there's many task force to driving this, journey for China to get the regulation unlock. I think, that's something, we're also leveraging this meeting to provide more technical perspective to, drive this initiative together as food and beverage industry.
Wonderful. Thank you so much. And I'm sorry we ran out of time. So let's see. Nope, that's actually not a question. I'm sorry. I was looking through online. Thank you so much. And if anybody still have any questions, use the Q&A function online, and I will make sure it goes to Dr. Miao or Dr. Wang. Thank you so much. And I would like to introduce our next speaker. And is our next speaker on the room, Dr. Bai Li. She's gonna talk to. Yes, how are you?
Good.
I guess
Thank you.
You're in line with me. Okay.
Yeah.
So want to make sure. Can you turn your camera so the folks can see you? And the topic that Dr. Li is gonna introduce to us is what's the application and new approaches toward next generation risk assessment. Interesting topic. We are very glad that you are going to share your experience with us. It's something I deal with it daily. Risk assessment every day, trying to figure out exactly how can we always keep our food safe. And the specific for what Dr. Li is gonna present, I'm gonna leave it up to her, but I would like to introduce her. Dr. Li is actually the Director of Division 1 of Risk Assessment, National Center for Food Safety Risk Assessment, CIFSQ for China. She actually have a wealth of experience, over 13 years experience in food safety sector, was focused in molecular, epidemiological, and microbiology, foodborne diseases, surveillance, and microbiological risk assessment. She's been involved in multiple national projects for foodborne pathogens. And also she is a member of the National Committee for Food Safety Standard and the National Committee for Food Safety Risk Assessment. And she's a distinguished expert for the joint FAO and WHO expert meeting on microbiological risk assessment, which is it goes by JEMRA. and she is a member of the World Health Organization Advisory Group for Foodborne Diseases and Burden Epidemiological Reference Group. Excellent experience. So without due delay, go ahead and please enlighten us. And we're really looking forward to hear about this. It's personally, I am interested in it too, very much. Thank you. Go ahead, Doctor. Are you able to, can you unmute yourself?
And thanks, Joseph. They will
you.
play the video because I recorded it before.
Okay, so let's for the technician in the room, can you please play the video? My apology if it's gonna take a couple of. I think we are not having the technician to run the video. The pre-recorded presentation. Let me IM them really quick. And
各位线上的专家、老师，大家好！非常感谢主办方的邀请，很荣幸能够参加第16。
Thanks to the organizers for your invitation to join the 16th International Conference. My name is Vali. I'm from China National Center for the Food Safety and Risk Assessment Center. So today my topic is about frontline new technologies we used on the food safety and several parts of by presentation. We first be as an influence of the advanced technologies. We know that 2013 in order to promote the new technologies, the US FDA and organized the team. They make such a consortium on the global coalition for the regulatory science research. And in order to promote the advanced technologies applied in the food safety, but together with them, we're trying to also initiate relevant the activities. It involves the government and officials, the officers, and the experts, and scholars. I think that this is 2014, and of this coalitions have organized the annual meeting, and we can from this list we can see. Then 2014, this is the whole genomics, and by 2015, this is the bioinformatics. 2017, the whole genome sequencing. 2017 is nanotechnologies, and then traditional Chinese medicines. But right now, it's about artificial intelligence used in this food safety monitoring. Let me give you two examples. But then this is the metabolism mix, and also for the food, cosmetics, and the drugs, and how we use that. But first thing is for the food and with the metabolism mix, and we have to identify 80,000 food about chemicals to 20,000 contaminants, and for the cosmetics, and there's the identify 10,000 cosmetic, the chemicals to 2,000 plus the contaminants, and also the nanotechnology. The 30,000 drug contaminants, etc. And for this chart, this is based on the RNA sequencing data, and this is by using artificial intelligence to make modeling. Then we, by using very advanced technology, we can collect the data. This is based on bioinformatics, and then we can form such a multi-dimensional chart. Actually, the EU in this year in May, they provide guidance of to promote advanced new technologies applied in this field. But there is the genomics, and also applications of the omics, the bioinformatics, and they set up the relevant targets. Then the division for the EU by 2030, the app setup will routinely apply with the omics and related to bioinformatics about being the food safety assessment. The background is it mentioned about application of the scope and which field should be further facilitated. It mentioned about the genomics and also the bioinformatics and the metabolism mix, and also the regulatory monitoring the aspect are also mentioned. Then, but the scope of the target general goal is to and during the food safety monitoring and to further promote the relevant method and also to provide more suitable and scientific tools and in order to address the challenges brought by the food safety assessment. Yes, the talking about to support for the open and by investment, but the techniques and therefore to further apply for the dynamics. Also, we mentioned about the development framework activities and then try to make the next shift and then to set up the big data library and to set up the new collaborations with them to open source and to artificial intelligence and other the advanced technologies. The next one to talk about this next one to introduce about this the applications of dynamics of the technologies of the food safety assessment. And from the chart we can see this is since the 2011 and in several months and in Germany and there's the outbreak of the STEC in 0104 and later on it involves about 14 countries and of course 400 cases and about 15 reported 15 deaths. Then for quite a while the pathogen was not detected and the professor the Yang Weifu and Huada the company and properly tried to make this the sequencing and also identifies those some of the accepted toxicity but toxical of things substances in the about like a chloride which adhere to the cell of the intestinal system and with the sequencing technologies which will build solid foundation for the further studying the pathogen about which will towards the global wider applications that provide such a collaborative global model. And based on the following investigation, they in the beginning people thought about the cucumber could be the host, but later on with the sequencing technologies actually this is a carrier of seed of carrier of those pathogen which will cause the outbreak of L1 L4 problems. And based on this case, we see the microbial that can cause very long-term problems that could be from the farm and to the table, and but it could last for a while because this case will last for 2 years. And so it influences widely, and they expected this case the urge of the EU and to set up such a the dynamics of the monitoring working group. And let's see the latest case. This is the very cases that with containment of the chocolate that caused the outbreak of problems by the salmonella. This identified unknown by ST3 of course the infection of the chocolate which caused the problem. After the investigations to such a factory, the factory was canceled with the manufacturing license. And later on, there's the case callback. And later on in April, the Chinese customers we suggest the Chinese consumers will pay more attention to such a brand of a series of chocolates. And after announced about 17 relevant regions, countries, and it has this outbreak and about 100 cases. And most of the victims are the kids. And the hospital rate is about 40%, but it influence with the big influence. But if it doesn't directly into the China market, but someone of shopping online, they get this is chocolate, which will cause in some cases. And then later on, Chinese authorities and they issue that, then we should observe that from the laboratory level and with the superior combination technology of the omics and genomics, and then we can fastly screen and detect such a problem. Then we can make it with the fastest speed, or we can identify this case and to control it.
The next case I would like to share is the sword attribution. Through omnic technology and machine learning, it will help us to identify the source. The outbreak of salmonella among animals is very common, and it's quite a challenge for the contamination control. It could be originated from bovine, poultry, in cows, and in swine, etc., etc. However, by utilizing the omics technology to source the attribution to the origin, by analyzing hundreds of sources, and by utilizing the machine learning technology and build up the models for sourcing attribution and precision prediction. The other example we can share is the chicken and the eggs, the farmed chicken and the eggs. And the supply of the live chicken are kind of monopolized by two big companies in US and in Europe. However, the sudden outbreak all over the world, the source cannot be identified. By selecting and analyzing samples and utilizing the omnic source attribution analyzing and the bioinformation, we realized, the major reason for decontamination throughout the world. And in the safety evaluation system of bacteria for industrial use, for food additive, enzyme preparation, for food and feed, etc., is also used. So and also such technology and information is well utilized in the drug resistance risk assessment based on omics and bioinformation for AMU and AMR. The recent article published by Chinese University of Agriculture and veterinary technology also stated that such technology had ensured the public health and safety. One of the research team led by a professor from the Hong Kong Polytechnics also came up with the evaluation framework as the qualitative drug resistant risk assessment based on the omics and bioinformatics. So such technology has contributed in the fast tracking, fast detection of the outbreak and the source attribution. Next, I would like to share is the limitation and challenges of the food safety risk analysis framework. So the risk analysis and risk assessment, we should use the priority listing and risk assessment and risk classification, risk management. Based on the principle of risk assessment, we should estimate and predict the scientific procedure to determine the possibility of the risk exposure. For example, the L monocytol genes is highly lethal. It could lead to 20 to 30% of death and 97.7% of hospitalization. And young children and OPI children group with high risk. In 2004, which is about 2 decades ago, the microbial risk assessments of such bacteria in instant food had already been published. The models had been established in common instant food, in dairies, ice cream, fermented meat, and cold fish product. And also the CAC guidelines published in 2007 and 9 had stated that whether the bacteria is a growth promoting or not, based on whether it's growth or not, they have different standard. And the outbreaks are occurring more and more often, and also the analyze per year on the median cases per outbreak. We can see different areas, even for US markets. For the frozen food, that is zero tolerant towards the non-growth promoting bacteria. So scientists around the world realized such zero tolerance policy is not yet the best solution. So last year, we launched the new risk assessment on the risk assessment to reconsider the source attribution, their characterization, and the monitoring of L monocytogenes. Some of the examples of the situation, for example, if in the instant food sample, it's characterized that is not allowed greater than 100 CFU per gram. However, if using detection technology is about 90 CFU G, do you want to recall the product or not? However, if you use the WGS product, you can realize it should be recalled. The second example on the toxicity, if the result is around 100 CFU, do you want to record it or not? So we have multiple examples. I will not deliberate on it. In China, we have very strict surveillance towards the LM. Most of the time, we hold the zero tolerance policy. The surveillance of LM in China shows a different trend, which means that the consumer behavior in Chinese market is also different. So we should choose our special guidance on monitoring surveillance in Chinese market. Salmonella contamination is one of the biggest problems for global diseases. No matter is the outbreak or the acute outbreak around the globe. So when conducting the source attribution, we use different approach and detect on different sources. Unlike the other markets, we are focusing on the raw livestock meat instead of the raw poultry meat. So why is that? Why are we focusing on the raw livestock meat instead of the raw poultry meat like the other European and US market and countries? If we take a look at the distribution of consumption volumes of the livestock and poultry in US, in EU, and in China, we can tell that the consumption of the pork, i.e. the livestock meat, is the biggest part. And also the contamination is more serious in Chinese market found in pork. However, people would argue that Chinese people turn to cook the meat before consuming and eating them. However, we can tell there is a wide connection. The outbreak is mainly in household, and in EU and American market, the outbreak is mainly in the restaurant, which means when you bring the raw livestock meat back home, there are a population that is susceptible to the outbreak of salmonella. So when it comes to the risk determination, we define that pork is the major source for the outbreak in Chinese market. And we collect the surveillance data, we conduct a survey on the consumption models and simulation and predict the outbreak. And also the uniqueness of Chinese market on the distribution of the serotypes of dominant non-typed salmonella in China is spreading from south to north and is differentiated between south and north. And also we focus the attention on the research in provinces, which is the major origin production of livestock meat in Chinese market. As mentioned, that in Chinese behaviors is that we turn to cook the meat before eating them. However, we need to collect more information about the consumer behavior. Collecting the data from Chinese market, we can tell that the behavior on purchasing and transportation, the storage, the way of cooking, and the way of operation, the cutting board, the maintenance of the kitchen table, etc., etc. We have the analyze on the cooking practice and consumption patterns. We conducted the survey in the city of Chengdu in China. According to the 6th national census in 2020, the population of Chengdu is 16.58 million. The annual number of salmonella cases in Chengdu is residents is 270 to 1, which means the percentage of outbreak of salmonella in Chinese market is quite high. The reason is that in Chinese market, there is no standards of raw animal meat product and production hygiene specifications yet. Take a look at the control measures of salmonella in poultry in US market. The biggest contamination source is the poultry, the broiler. So in 2017 and 2021, the standard was established as the source to be reduced into 50%, so that we can reduce the possibility of determining the population. However, it turned out it's not effective to lower the infection in the population. Then they realized that the key is to, in the reduction of proportion of poultry samples, salmonella.
And also, it's been like this, and we seriously consider what can we do in China. For Europe, and EFSA, but in the early stages, they already started this, but the investigations, but then they will try to reduce the contamination caused by the salmonella in the chicken. In China, according to the Chinese case, the infection was by the salmonella, and then actually in 2018, but these actually characteristics of the war were mentioned by the published the article. And because according to the characteristics compared with the the type of salmonella, we see the increased cases that are related to these the salmonella. Therefore, but we can see such an infectious the phenomenon is increased in Europe, and this is relevant to this, but the clone. The clone and also the UP of drug resistance, but is related to this phenomenon. This is the ST34. Also they have such a drug resistance to the element of the iron and copper and zinc. So that's what we are selecting this ST34. And also we check on this the Henan province, which is quite famous for the poultry meat and pork. Then we select the 100 samples. Then so on the left on the top, according to the column, column chart, and you see this the MDR is about 97% about the drug resistance, and then 73 for the SSUT. Then we do the investigation and on the desk case. Also, we just download those cases with data and from the Europe and from North America, and then we make the whole is the omics the investigations that according to the omics of the working principle, and we made a comparison that red means the strain in China, the green means in US, and the blue is in the yes from Europe. But we can see for the red color is the very similar source from the Europe, and also those is the cloning. This is the clone of the omics, and we can see the blue is the pink, but we can see that on the left, the pink is for China, the green is for Europe, and the blue for the US. But we think the Chinese, but the strength having the big differentiations, and also during in China, but during the manufacturing process, and then for the pink kind of shows to that the strain that could have the higher and the drug resistance. And from China, we can see according to the characteristics of the character pathogen. See on the left and the yellow means the C1, the purple means the C2, and we can see the obvious difference between these two. And we consider the C1 and get a mutation, and obviously higher than the C2. And the C2, so that also means that another mutation is higher, obviously higher than C1. And the C1 strain was born about 1993, and the C2 was born after 2000. And we can see the C1, C2, and the mutation, the genetic, the characteristics, but have the differences. But then later on, we can see the effective the strain increases, and afterwards it goes down. And we can see the C1 goes down later on, but C2 it goes up. And according to the past 20 years cases, and with the further investigations, we think with the global, especially for the feeding chicken is a breed. A breed chicken of a breed one then receive some of the new strain of accurate band which is a little bit more spread of the salmonella. It's just like the Russian baby dolls, and we can see it derives from the previous generation. But later on, it carries the different genes with the genetic mutations which have the higher drug resistance. But now, for the genomics of all mixed and then provide such a solid foundation for our the further improvement and further investigations on the full cycle monitoring on these salmonella related bacteria. And the final work is that in terms of for the safety management of the framework down the food related microbials, but this was the first year according to those public health issues. Then we should set up the risk management and then to set up the formula of the FSO and make sure it is feasible, therefore to control those possible risks. And also, first of all, we should the first of all, we should primarily to make the food microbiome, but the combination, the assessment according to the Chinese conditions on this the food sources of infection. And then firstly, according to the food of the hazards, we should make a classification of the risks and then to set up the top priority targets. Later on, there's a document issue. And we need to use the integrated method and to deal with such the antimicrobial and also drug resistance. And the previously it was organized by the FAO, UN, and the OIE, and also the WHO. But now we have another channel and to closely monitor the phenomena and therefore and to make the overall cycle monitoring and assessment on the drug resistance. The above mentioned about the Chinese consumption method in terms of those meat product, and because of the Chinese, the advantages, the strain is different from the overseas ones. But then now we start to reinforce our foundations and to make further investigations. But then we must form such a Chinese conditional based on the data actions, and also those quantitative data should be made. Also, the cross infectious data should be made, and also the localization of the assessment of them. They also refer to international standard. All these factors should be considered. Then what we are working on right now is omics and the informatics. I think the very important point is that we should know the relevance between each other. But if you can conduct an investigation on the trial, then we just refer to the data. But it's beneficial for us to identify the advantages of the toxic strain. Then we can download data, then we to calculate the probability, and then to make the elastic analytics, and therefore to make sure the accuracy of the data of the indicators. And consist of the data we download is just the partial, then the plus the genomic set of all mix, and then we are able to compete with the data sets. And all these should be based on the risk of monitoring, and then we should closely watch it, and also to make and to so through the risk of assessment and to better comprehensively evaluate the risk of particular countermeasures, and then we should evaluate the source of the process control and to prevent and make a precaution of the risks of the food source of infection.
Thank you so much, Dr. Lee. Can you hear me? We have actually we have a question that came online. So
yeah, I saw it.
Yeah, can you go ahead and answer?
Yes,
actually, we need to read the question for the audience. You want me? Let me read it really quick. Regarding the salmonella infected cases in Shandu, how do we know they are related with contaminated meat? Will it be possible they're caused by personal hygiene management, like proper hand washing? And the question also say, I heard one of TED lectures showed the importance of hand washing in India, you know.
Thank you for the question, and thanks for the question from the audience, Bao Xie. I think that is really a good question, as this question can really tell me the total difference from China and abroad. As we all know that the salmonella caused by abroad is made from the recipe is from the uncooked meat. And also from the cross-contamination. But we all know in China, we may cook the food, we do the meat is well cooked. So in our study, the hypothesis is that all the meat, even though it is contaminated with the salmonella, there is no risk from the cooked meat. The risk in our study is from the cross-contamination. So if the meat is contaminated with the salmonella and it takes home, if the cooker didn't have the good habit, and it's very easily to translate the salmonella from the meat to other food or other ways. So in our study, the risk issue is from the cross-contamination. So the audience is right. Have food hygiene in the house is very important in China. Thank you.
Awesome. Hey, it's an important topic and definitely it resonates a lot. I don't know how many of the audience and seen the video that my colleague presented yesterday for the Stephanie story and how she lost her unborn child to listeria, to LM. It hits right there, and I'm very impressed with the work, the risk assessment that the China National Center for Food Safety Risk Assessment is doing. I have one quick question, and if you could please answer it as brief as you can, because it's still an important question. You really presented a lot of work being done, but in your expert opinion, how long do you think it takes to translate that innovation in technologies regarding regulatory to actual regulatory application?
Thank you, Joseph. I think this is a very hard question because as we know, there are a lot of innovations, but how the innovation can be translated into the regulation is really difficult. Normally, it takes a long time, maybe 10 years to 20 years. And because it needs many steps, because as we know, at the beginning, the innovation is not developed for the regulation. Maybe it's just developed for the science or research. So maybe it's wrong, it cannot go ahead. If it is okay, and it will be used in the regulation, it need to be contain many aspects. As we know, the data can be repeated, and it should be standard, and also the data can be shared. So I think that it's just depend, but it really depend. It will cost a long time. Thank you.
I really appreciate it. We ran a little bit of the time, but we still have time before the lunch. So I would like to introduce our next distinguished speaker. Unfortunately, Dr. Yao Su could not be there in person. So she went ahead and sent us a pre-recorded presentation. I hope everybody will see the value of it. I want to introduce the topic. It covers the advances in accurate identification and viable count of microbial food culture. specifically probiotics. And I would like to introduce Dr. Yao Su. She's a vice president of the China National Research Institute of Food and Fermentation Industry. And also, she is the director of the China Center of Industrial Culture Collection. Dr. Su, she is a very distinguished in her involvement and expertise in this field. She's actually a technical expert for the ISO TC 34 SC9, which is a very distinguished, it's a Probiotic Society Institute of Food Science and Technology. She's a member of the National Codex Committee for China. And also, she was responsible to establishing the screening and evaluation platform to cultivate the core functional streams of traditional fermented food and realize the industrial application of it. Very, very distinguished experience. She hosted and taken part in 23 national research projects, authorized 12 inventions, patent, made over 20 achievement appraisals as a fellow for expert fellow, and 30 scientific and technological awards, over 120 academic papers. So we actually gonna be very interested to listen to her presentation personally. I don't know how many buys probiotic. I always buy it and I look at it and it say 10 billion, 10 strains. And I always, in my mind, debating, are they really accurate? Are those really viable? And so we're gonna be very interesting to listen to Dr. Su's presentation. So if the technician for the conference, if you could play the presentation, please go ahead. Sorry, it takes just a few seconds till the presentation is being displayed.
Joseph, for your kind introduction, and thanks for the invitation of the conference. I would like to take this chance to share the advances in accurate identification and viable count of microbial food culture probiotics. I apologize that due to the COVID situation, I cannot be here in person. Good morning to everyone. Thank you for your introduction and the invitation. So I'm here today to share some of the advances in the research work. I'm sorry I cannot be here. So the topic today mainly covers the following. Is about the law and regulation, the technical research, the method of study on viable count, and practice of the technology advances. Probiotics, with the fast development of the industry, the definition on probiotics are more widely understood and accepted is about the function on the health and appropriate amount of dose. When we talk about the determination and the accurate identification, there are several terms we want to emphasize. First is the species. The species level is really important level for identification. That means a general term for a group of strains that are highly similar in characteristics, closely related, and significantly different from other species in the same genus. So mainly when we talk about a group of the probiotics, we are usually talking about the species. The definition of strain is the progeny of a pure culture produced by an independently isolated single cell, usually consisting of a series of cultures originally isolated from the single colony. So we were also using the terminology of strain level. The determination and identification from the strain level is to the process of determining the key characters of microorganism according to the existing classification system using phenotypic identification technology and genotypic identification technology, and by comparing the known reference strains or databases distinguishing the major groups of bacteria, yeasts, and modes, or determining the level of genera, species, subspecies, and strains. When we talk about the strain typing, it is an important part of epidemiological investigation, clinical and public health microbiology to prove the microorganisms are of the same strain or origin by a strain typing. So the typing is about the epidemical investigation, and the identification is about the classification of the strains. They are different and related with each other. So based on the guidance published by WHO and FAO in 2001 on the evaluation of probiotics in food, it has set the standard on strain identification, safety evaluation, functional evaluation, efficiency evaluation, potency evaluation, and labeling standard. And in 2017, there is also a guidance from IPA to qualify the microorganism to be termed as probiotics, because there is a difference at the strain level. So taxonomy must be determined at the genus and species level, and probiotics must be identified at the strain level. In response to the revision on the IDF number 462, the guidance on the identification of probiotics at the strain level document updated had emphasized on the importance of determining the function of the probiotics, and also the importance of the identification on the species level and the strain level. The species level is really important, and many of the strain level identification cannot be used directly. It has to be identified at the species level. And multiple identification technology can be used to identify at the strain level for accurate identification. However, it should be selected based on the theory and the difference on the types. So on the species, the subspecies, the strain, the groups, each will have a suitable typing technology. And the whole genome sequencing technology analysis and the multi-omics technology had provided effective scientific support for further safety evaluation and functional mining of the probiotics. Such a guidance document will promote the future application of the probiotic products. And in USP, there are segments on probiotics tests, especially at the strain level. And the chapter in FCC on the microbiome culture, including on the polymerase chain reaction, which is the APR, had provided and facilitated the regulation and production of the probiotic products. It had stated that such method can be utilized in the process, in the production, which gives the faster and low-cost method. So the determination method at the strain level had been introduced, and it is quite a common way. The regulation in China, published in 2019 by the State Administration for Market Regulation, the Declaration and Review of Probiotic Health Food had mentioned that the applicant should be based on experiment at strain level, and some of the research and scientific documentation could be used as a reference for the file and the application. The evaluation, the methodology on evaluation, and the identification. We also published in 2020 the technical guidelines for safety testing and evaluation of strain used in health food raw material, and the safety evaluation procedure of National Food Safety Standard strain for food had similar requests on the categorization, on the strain identification data, on the documentation, and the evaluation assessment method had been included in the national guidance. And for the group standard in the industry, for example, in 2022, which is this year, the recently published General Standard of Probiotics for Food Use by Chinese Institute of Food Science and Technology had made it very clear on the request of the assessment at the strain level standard, and the standard on the lactic acid bacteria test and counting related standard in China had also been published. The guidance on the technical procedure, national safety standard on food safety, fermented milk, etc., which offer the reference standard on law and regulation in China. Globally, there are a series of guidance and regulations like ISO 7889, ISO 2128, and ISO 889 and 17, which are offered as the guidance. Some of them are among the revision procedure. However, there's a question for the determination and identification at the species level and the strain level. What kind of accurate identification, what kind of probiotics can we identify in the compound products? And what about the viable count? What is the number of the live bacteria in various probiotics products, which is quite a challenge for the industry?
And just I mentioned about the last year, the guidance was issued. And for instance, like those molecular, the genomics and the sequencing of those technologies are used, and also those sort of updates of the technologies like IP and IPF, and also based on the WPF, and especially with the SMP of the technologies mentioned. For instance, the IPD technology, so which is the fast, the quick, and the easy operated the technology, and also this is the mature the technology. It's quite helpful, for instance, to quickly and identify the strains. But compared with the other methods, in terms of the accuracy, a little bit of weakness. For this IP, the method easy to operate, and there were more of a model, and it can be used before. So commonly used in the clinical trial. Some of the positive bacteria is also used for those pathogen body bacteria and this method of skip PFGE. Compared with the previous two, the rapid ones, there needs to be many work invention, but in terms of the accurate classification, it is advantages. Many study based on this PFGE method, but they also very similar to the RP. But for probiotics, that allow them are the positive ones, and for PFGE, maybe there is some limitation. In terms of the regulation, also this is the strain specific PCR. That we should be more referred to the strains. For some it is the exclusivity, and for the scientific about the etc. But we need to be making a further investigation about after performing the model, and to find the average ones, but then later on it can be easier to use. This is very helpful for the industrial level application, for them to check the value of the strain. And we mentioned about that, so WGS and so what also report about the metal server WGS and or the single metal type of polymorphism SMP that can be used in terms of to detect that. But of course, before the discrepancy or the difference, then need of something to form the formal models to check. Also, there are a lot of articles that are relevant to the method based on WGS. In terms of the identification of the count on the probiotics, and the WGS is widely used, and then we widely use this method to check the maybe generation 2, generation 3 identification. And usually we just use it we use the WGS with SNMP the method to detect. I think this is a good ideal method. And for the mini ones, mini SNP, is being used. So the quick typing of the bacterium, the animal, the sample species of lactase, with strains in the milk products, and with this such a mini sequencing, and we can quickly find the mother gene group, and then to then we can make a screen based on the 9 different genomes, and then to find about genomes of the map. And compared with the SMP, it's quicker. It's a quicker method. And it is more widely used. In terms of the precise verification, and it's feasible for us to realize that but we are concerned about the sort of what kind of cost, what kind of time we should spend on that by using that method. But right now we have the sample method, the mature method, and to kind of those variables. But if this but if it has some infectious the bacteria or the some of the positive or liable pathogen the bacterials, I think currently it's difficult to realize that. But there are several methods to count the viable ones. In the recent years, we continue to study. For instance, recognize some the strains or groups. I think for this case, it is good, especially for those of the microbe-based these strains. Also, if there's some phenomenon that is maybe there's no but this is a good way. But this is a good way to tackle whether there is a reliable the probiotics in the immune formulations. And we hope we can work more together, and then we hope we can standardize those methods, and also the to use the PMA method, that we can combine these two technology. Then for the specific species or the strain, and we can make the identification. And we should check the strain by strain. We hope that we can work together with the scientific institutions and also the manufacturers to make about the in-depth, the precise count on viable probiotics in terms of at the level of the species or the level of the strains. But actually, this is not a new method. But for the analytic, for the extraction of the PMA, in order for the better PMA, the PCR, then because this is good for the specificity and sensitivity and the reliability method, and to check the species-specific primer. Actually, in the early stage of the manufacture, the dairy product manufacturer really use those mature method for quite a while. But in terms of for a there are the specific requirements on the double check on the species, and this is the common seed method, and you check the count of the viable probiotics. Now, right now, sort of we work with the Thompson. This is the some of the count of the viable ones, but then that we already published the outcome. Towards the combined probiotics with the megagenomics, and then we can make analytics on that. For different strain, different species, that we can make a precise identification and make a viable count efficiently. There's been a lot of efforts. This is a big workload. Right now, we don't yet perform a mature, comprehensive data library. Every time that we just check about case by case, and so we spend a lot of time and efforts on that. Every time we should set up a new model, every method will need to be validated systematically based on the current principle that is the quantitative data. So it's a big workload. But once we form that, then it's easier for us, much easier for us to operate. That's for me today. And finally, I would like to introduce our work by CICC group, and it was established in 1953. This is the institution at the national level for with long history. And also this is affiliated to CNIF. Now that there are 70 technicians and plus master degrees for students, and also the director level member of the CASM, and also the member of the WFCC, and also the SAPA Council for the CCCCM. Now, also that we are the interface in this unit, and also the secretary for the four international institutions. Now we're dealing with the preservation, distribution, modification, import, export of all the industrial microorganisms, and also we focus on the developing of preserved strains, the more than 12,000, and we conduct the international exchange on the expertise, and welcome you to visit our website, and we are willing to keep in contact with you in the field of the probiotics, and we hope that we'll work closely with the relevant scientific institutions in terms of probiotics, and that's for my sharing today. Thank you for your support. Because we are deeply involved in those standardization, the standards of drafting, but we hope that we can exchange more with the experts and scholars. Once again, many thanks for the organizer for inviting me to share. Thank you.
Sorry, I was on mute. Thank you so much, Dr. Su. It's very informative. For the audience, you are in the room and you have a question, please raise your hand in the microphone. Mine have a question, please go ahead and use the Q&A function. I do have a question. Is there any regulation regarding probiotics and that you're aware of, whether it's in China or in other countries? Is there a regulation regarding how, when you label it and you're selling it as a nutritional supplement, is there any current regulation that you're aware about? I don't know if Dr. Su, you were able to unmute yourself or hear the question. I will go ahead and email it to you. And meanwhile, I really thank everybody that participated, between the distinguished presenters and everybody that attended this session. And I hope we can all meet again in person in Beijing for the next China International Food Safety and Quality 2023. Thank you so much and enjoy your lunch. Thank you.